Hello viewers. In this video lecture, we are going to see on topic combining multiple learners from the fourth unit, that is ensemble techniques and unsupervised learning for the subject artificial intelligence and machine learning. The objectives are to understand the need of combining multiple learners and to understand the different schemes for ensemble learning. Ensemble learning is one of the most powerful machine learning technique that uses the combined output of two or more models or two or more weak learners and solve a particular computational problem. For example, random forest algorithm is an ensemble technique where it will take the output from the multiple decision trees. Ensemble learning is used to improve the model performance such as classification, prediction, function approximation, etc. When designing a learning machine, we generally make some choices like parameters of machine, training data, representation, etc. This implies some sort of variance in performance. So, we can use a parametric classifier or in a multi-layer perceptron. We should also decide on the number of hidden units. So different learning algorithms have different accuracies. One theorem is telling, that is the no free lunch theorem is telling that no single learning algorithm always achieves the best performance in any domain. So they can be combined. Different algorithms can be combined to attain the higher accuracy level. Data fusion. One method is called as data fusion. It is the process of using multiple records, fusing multiple records representing the same real world object into a single consistent and clean representation. Fusion of data for improving prediction accuracy and reliability is an important problem in machine learning. So the combining different models is done to improve the performance of deep learning models. Building a new model by the combination requires less time, data and computational resources. And the most common method to combine the models is by averaging the multiple models, where taking a weighted average improves the accuracy level. Generating diverse learners. So what are the things are used to produce the different learners? Different algorithms. So different algorithms can be used for the different learners. We can use different learning algorithms to train different base learners. So each algorithm can make different assumptions about the data and lead to different classifiers, different hyperparameters. We can use the same learning algorithm, but we can use it with the different hyperparameters. Different input representation. Different representations make different characteristics explicit, allowing better identification. Different training sets. Another possibility is to train different base learners by different subsets of the training set. Model combination schemes. There are several methods are used for generating final output for multiple base learners or multi-expert and multi-stage combination. Multi-expert combination methods have base learners that work in parallel. There are two types of multi-expert combination: global approach and local approach. Global approach is otherwise called as learner fusion. A local approach is otherwise called as learner selection. In global approach, given an input, all base learners generate an output and all these outputs are used, such as voting and stacking. Local approach, in mixture of experts, there is a gating model which looks at the input and chooses one of the learners as responsible for generating the output. In multi-stage combination, methods use a serial approach where the next multi-stage combination base learner is trained with or tested on only the instances where the previous base learners are not accurate enough. Classification. When the output takes values in a discrete set of class labels, where k is the number of different classes, regression consists in predicting continuous ordered output. Voting. The important method used for the combining multiple learners this method is called as voting. The simplest way to combine multiple classifiers is by voting, which corresponds to taking a linear combination of the learners. It is ensemble machine learning algorithm. For regression, a voting ensemble involves making a prediction that is the average of multiple other regression models. A voting classifier is a machine learning model that trains on an ensemble of numerous models and predict an output based on their highest probability of chosen class as the output. It aggregates the findings of each classifier passed into voting classifier and predicts the output class based on the highest majority of voting. The idea of instead of creating separate dedicated models and finding the accuracy for each of them, we create a single model which trains by these models and predict output based on their combined majority of voting for each output class. Voting classifier supports two types of voting, soft voting and hard voting. In hard voting, the predicted output class is a class with the highest majority of votes. For example, there are three models, three learners. Three learners are providing their predicted output A, B. So the majority voting result is A and the final prediction value output will be A. In soft voting, the probability values will be the probability prediction probability values provided by the different learners will be averaged to find out the final value, and based upon the highest probability value the final class will be confirmed. Suppose given some input 3 models, the prediction probability for class A is 3 models. First model providing the calculating the probability of A 0.30, and the second model calculates the output value for the class A is 0.47, and the third model is finding out the probability value for the class A is 0.53. So 3 models probability value will be averaged. So we are getting the final probability value for the class A is 0.4333, and similarly for class B, 3 prediction models are providing their own probability values, and when we take the average value we are getting 0.3067 for the class B. So when comparing the probability, when comparing the probability value of class A and B, the highest probability is possessed by the class A. So the final conclusion is final output will be class A. This is called soft voting. So in voting, the first step is to create multiple classification or regression models using some training data set. Each base model can be created using different splits of the same training data set and same algorithm, or using the same data set with the different algorithms. Learn multiple alternative definitions of a concept using different training data or different learning algorithms. It combines the decisions of multiple definitions. This is the diagram. So n number of base learners are there, n number of data sets, individual data sets will be applied to the base learners, and each base learners are constructing their own models. And finally, all the models will be combined, their some features, their contributions will be combined, and final model will be produced. So this is the actual concept of combining multiple learners, or combining the outputs of multiple learners to improve the performance or to improve the accuracy level of the final output. That's all about the topic. Thank you.